Imagine your company's entire network goes down because a junior help desk operator accidentally wipes the recovery configuration. How do you stop that, before it even starts?
Well, you have to lock it down early.
Right. Welcome to your deep dive. Today, we are taking a very deliberate, slightly slower-paced deep dive, specifically tailored for you, into the HPE6-A90 exam.
Yeah, if you are looking to master modern network management, this is exactly where you need to be.
To really understand this, we are going to explore the life cycle of a network by walking sequentially through exactly 7 practice questions. So before we even plug a device in, we have to secure who can touch it. Question 1. Which feature in the management platform ensures that a junior help desk operator can only view wireless client connection statuses without being able to modify any device configurations? The correct answer is A, role-based access control policies.
The mechanism behind role-based access control, or RBAC, is what makes it so secure. It is not just a polite request, The system's architecture literally disables the right access API, calls for that specific user profile.
So it is like a museum pass. I mean, you can look at the exhibits, the connection status, but you absolutely cannot rearrange them.
Exactly.
The system physically disconnects their keyboard from the control panel.
Right. They are totally locked out of making changes. So once administrators have the proper access sorted out, how do we actually bring those devices online?
Well, that brings us to question 2. When provisioning a newly purchased access point in the cloud environment, which prerequisite must be satisfied before the device can successfully connect and download its initial configuration? The correct answer is D. A valid subscription must be assigned to the device inventory entry.
Yeah, this step basically governs device onboarding. In a cloud-managed HPE Aruba environment, merely adding the hardware to your inventory list, well, it isn't enough.
Really?
Yeah, it requires that valid subscription to actually access any cloud services.
Wait, I want to push back on the logic here. Why design it that way? So the physical device is plugged in, but the cloud basically ignores it until the digital paperwork, like the subscription, clears.
I know, you would think it would just connect.
Shouldn't it at least download a basic security patch locally first?
Well, from a security and scale perspective, the cloud acts as a zero-trust gatekeeper.
Okay.
Yeah, until that subscription validates the device's cryptographic identity and licensing, the cloud treats it as an untrusted brick.
Wow.
This is what prevents rogue devices from infiltrating your management environment.
Okay, that makes sense. So now our devices are online, they are verified and subscribed, but hardware fails.
It always does.
Right. Question 3. An administrator wants to automatically notify a third-party IT service management application whenever a critical network gateway goes offline. Which mechanism provides the most efficient real-time integration for this requirement? The correct answer is B, outbound webhook notifications.
Think about traditional syslog files. They are like a security guard doing rounds every 15 minutes.
Right, on a schedule.
Exactly. You only find out there is a problem when they check that specific spot during a batch process. But a webhook, however, is an event-driven HTTP callback.
So it is a tripwire.
Yes, perfect analogy.
The exact second the gateway falls, it snaps the wire, instantly pushing an alert straight to your ticketing system.
Right, in real time.
So we have secured, provisioned, and monitored the devices. Next is maintaining them. Question 4. To maintain strict security standards, an organization requires all edge switches to run identical software versions. How can an administrator enforce this requirement globally with minimal manual intervention? The correct answer is D, by applying a firm software compliance policy at the group level.
So the management platform is continuously pulling the firmware version of every device in a group.
Just constantly checking.
Exactly. If one switch is out of compliance, it automatically forces a downgrade or upgrade to match the rule.
Group-level policies are like a mandatory uniform then.
Mm-hmm.
It is seamlessly applied to an entire department without having to measure everyone individually.
That is exactly how it works.
But what happens when standard uniform configurations just aren't enough? Question 5. When deploying a large number of switches that require highly customized and distinct configurations that cannot be standardized through a visual interface, which organizational method should the architect choose? The correct answer is B, template-based configuration groups.
Visual graphical interfaces are great, until they limit your flexibility.
Right. They only give you so many options.
Yeah, template groups use raw code with text variables, like inserting a placeholder for a specific IP address.
Oh, wow.
It allows for massively customized, automated deployments at incredible scale.
This sophisticated, flexible management It really points to a massive underlying architectural shift.
It absolutely does.
Question 6. In contrast to previous generations of the wireless operating system, what is the primary architectural shift introduced by the newest version regarding configuration and management? The correct answer is B. The management plane is entirely moved to the cloud platform.
Let's define the newest version, which is AOS 10. Think of AOS 10 as the brain for these devices.
The brain, right.
Previously, the brain lived on local physical hardware called mobility controllers, sitting right there in your server room. Now, all that management intelligence lives entirely in the cloud via HPE Aruba Networking Central.
Wait, so we are entirely moving the management plane to the cloud platform, abandoning the old local controller models.
Yes, we literally evicted the local management hardware from the building entirely.
That is a huge shift.
It is, and it streamlines operations. But moving the brain to the cloud makes on-the-ground high availability absolutely critical.
Which brings us to question 7. When designing a high-availability architecture for enterprise gateways operating on the latest cloud-native operating system, what is the recommended approach to ensure seamless client failover? The correct answer is C. Deploying the gateways as an active cluster.
An active cluster just means multiple gateways share the workload simultaneously.
Okay, at the same time.
Right. If one hardware gateway physically dies, the other gateways already have the client's session state.
Oh, so the tunnel services shift instantly without dropping the connection.
Exactly. Seamless client failover.
So to recap our technical journey for you today, we have moved from basic RBAC and cloud provisioning through event-driven webhooks and compliance to cloud-native clustering. It is a complete look at